Let's look at this problem. The problem is minimum difficulty of a job schedule. It is marked hard, but is not that difficult to solve. So we are given a list of jobs and number of days as D, and you are asked to divide these jobs in D days to find minimum difficulty of job schedule. Now, how do you define minimum difficulty of a job schedule? It is the minimum difficulty you get. And how do you define difficulty of a job? It is um, summation of all the difficulties you get on a day. And for each day, uh, to get the difficulty of a day, you have to find the maximum job difficulty that you do on a day. So that's a lot of difficulty, but this problem is not that difficult at all. So you are given this array and now you are asked to divide it. So when you think about it, it's asking nothing but to divide this array into contiguous subarrays. That is, uh, let's say these work you do on day 1 and these on day 2. So what are these forms? These are just contiguous subarrays of the original array. In another word, you are just creating a partition uh, of of size which is one less than the number of days. So these partition will create contiguous subarrays, and for each of these subarrays you can find the maximum in that subarray and add those to get the difficulty of job. So that's all the problem is, that you have to find d minus 1 partitions such that you get the minimum difficulty. And how do you do that? So one way is to find all possible cases, that is to create partitions of all possibility which we can do. So let's say you're given this array 4, 3, 2, 1, and then you start from let's say job 1. Then for each of these job, um, you can try doing that partition. So let's say you do uh, this job of difficulty 6 on day 1. So you can create one partition here, or so this will form a tree like structure. So let's say you have done partition here. You can also do partition after 2 jobs. 4, 3, 2, 1, and similarly, like, you can try all partitions, and for uh, each one partition you are doing that, you have created day 1 here, and now you will get a new sub problem in which you have number of days reduced by 1, and now you have to find the difficulty for this subarray. Then you will get the answer maximum in day 1 plus the job difficulty of this subarray. So this will again form a tree, and like that, similarly this will also form a tree based on how do you decide to partition it. Okay, so what all things are changing in our this tree diagram? So one thing we are changing is the index and also the days or partition. So here you had day 2 or partition 1. After this partitioning, you will have day 1 or partition 0. So whenever we have 0 partitions left, that is the time that is when we are at our base case. Let's say you have partitioned here. Now you have 0 partition left here. So how do you get the answer? Just find the maximum till this array and then maximum in this array. You add this and then you will get the answer. So that's all in this problem. You have two variables which are changing. So you have to store them in some, let's say DB table, so that mm, you don't have to do redundant task every time. Okay, that's it. Let's look at the code now. D is the number of days and job difficulty is the array of uh, jobs containing difficulty for each job. So if we have D days, what will be the number of partitions which we need to do? So that would be D minus 1. Okay. And now let's create a function. Uh, let's name it difficulty. And what we want for in this function is that if we pass an index and the number of partition which we need to do for job difficulty, we get the minimum difficulty of a job schedule. So what are we going to pass here is index from which the uh, day starts, then job difficulty. Let's name it JD and the number of partitions. Now, so what we will do is start our iteration from that index. So index I less than JD dot size 5 plus plus, and for each of this index we will try to do a partition, and the minimum difficulty which we get from this will be our answer for that index and that number of partition. So let's create an answer variable. Um, let's give it its initial size of 3e5 plus 1. So why this? Because the constraints are given that job difficulty is of 300 and job difficulty I is of 1000. So that's 3 to the power 5, 3 into 10 to the power 5 is the maximum possible sum which we can get. So our answer should be greater than that for finding the minimum. So initial value should be greater than that so that it doesn't lie in the range of one of those answers. So also we will declare a variable which will contain the maximum difficulty of the day. So let's give it an name and initialize it with int min. And for each day, we will find maximum difficulty. JDI. So this will give us the difficulty of the day, yes. And then answer will be minimum of all possible. So that's answer plus n, because we will add that difficulty of the day and then ask the sub problem to give us the minimum job difficulty of the smaller subarray for p partitions. So let's give it the name difficulty again because that's the subarray, that's the function. We will go to index plus 1 because we are creating a partition, and then JD and number of partition will be reduced by 1. Then after this we can finally return answer. Okay, now what will be the base cases? So let's say uh, if at any point you are standing at the ending of the array, so that is like, let's say you're standing here and then could you do a partition after that? So that's a no. You cannot do partition after that. So whenever you reach whenever there is an index which is of size jd dot size, that is when you have reached the ending index and the next index is the outer bound, then you can return a number which is not possible. So that is 3e5 plus 1. So that's one of the base cases. And another base case would be when the number of partition has become 0. So that is when you have done your job. That then what you have to do is to find the maximum of the remaining subarrays. So let's say here RD for this is 2 and then number of partition is 1. So let's say you create a partition till after 3, then these will be the subarray which is remaining after that. So we have to add this sum to our answer which we get before that. So we have to find maximum after that index. So we will return max element starting from index going to jd dot end. Okay, and then we can finally call for the answer. That would be difficulty. We are starting from index 0. We will pass this job difficulty here and number of partitions as p. Also, whenever this answer is not possible, we will have to return -1. If the answer is greater than or equal to 3, 5 to 3, 10 to the power 5 plus 1, then we have to return -1. Else, answer. Okay, let's try. Okay, this t should be 2 because we have given the name p as number of partitions. What else? Okay, that. Okay, we got accepted, but this won't run. It will give time limit exceeded because we are calculating redundant steps here. So how do you reduce that? That is by memorization. So let's create a DP array, 2D DP array, and what we are trying to store, what are the variables which are changing? It's index and partition. So we'll store index value. It is given index can go up to 300. So let's give it a size of 301, and number of partitions can be of 1000 size. Sorry, number of partitions would be of 9. So on to be on safer side, let's give it 11. So we have done that. Now let's initialize this by using set mem dp -1 and then size of dp. Now we have done that. Now let's check whenever we encounter that index and partition, then we can directly return the answer. and also for each of this value store it in the memoizing table. So it will be dp index and p. Let's try again. Okay, let's test on all cases. It got accepted. Thanks for watching.